All right, so this video is going to go over pages 8 through 10 in your projectiles packet. So feel free to stop, fast forward to whatever you need to. This will be kind of a little bit of a longer video since it's just a lot of example problems, but hopefully this will help you understand a little more. So number one, an object rolls off 10-meter high cliff. So what I'm going to do is I'm going to draw my cliff so it's 10 meters high. Okay, and it has a horizontal velocity of 5 meters per second. So it's going off at 5 meters per second. So here's our trajectory. Okay, what we're going to do is we're going to set up our t-chart. So we have our x, we have our y. So remember we have vx, dx, and t. And vertically we have daffy t. Okay, so they told me the cliff was 10 meters high, so that is my vertical distance. So be careful with where you put it. That is not your horizontal distance, that is your vertical. And since it's falling, we're going to put a negative 10. Now, A is going to be negative 9.8 because gravity is affecting it. And remember, our initial vertical velocity was 0. Now, it also gave us a horizontal velocity of 5 meters per second, so we're going to plug that in for our Vx. It wants to know how long will it take the object to hit the ground, so you're looking for time. Now, I do not have enough to solve for on the left side, so what I'm going to do is I'm going to solve for on the right side using my daffy t. So we're going to use that equation number 3. So remember, d equals VIT plus 1/2 AT squared. But remember, VI is 0, so this whole thing goes away. So don't keep that t. So we're going to plug in, so negative 10 equals 1/2. A is negative 9.8, t squared. So I'm going to divide both sides by whatever 1/2 times negative 9.8 is, which is negative 4.9. And you're going to get 2.04 equals t squared. So please be careful with this. Do not forget to square root at the end because you cannot leave it as t squared. And you're going to get a time of 1.43 seconds. Okay, so that time can be used on both sides. Okay, so I can take that time over here to the left side because B asks for what is the range. That is horizontal distance, so we're looking for dx. So remember, we're going to use Vx equals dx over t. So Vx is 5. Dx we don't know, and time is now 1.43 seconds. So multiply both sides by 1.43, and you're going to get a horizontal distance of 7.15 meters. And there's your answer. That's it for those two. Number 2, a soccer ball is hit horizontally from a roof. So again, I know a lot of things are being launched off of roofs and stuff, and it doesn't really make sense. But that is type 1 projectiles, is when something is being launched off of horizontal surface. Okay, so being kicked off a roof that is 65 meters away. Okay, so 65 meters away is your horizontal distance. Okay, that is not, and I would say 65 meters below if I meant to be that to be a vertical distance or height. But 65 meters away, that is your horizontal distance, and I gave you time. So what we're going to do is we're going to set up our t-chart. So x, y, okay, so Vx, dx, and t. And we're going to set up our daffy t over here. So we're going to go with what we know. Okay, I know 65 meters away is my horizontal distance, so that is going to go right here on my left side. Okay, my time is 5.5 seconds. That goes on both sides, so don't forget to put it on both sides. Okay, and a couple of implied things we know about is, remember, A is negative 9.8. That's always going to be the same. And your initial vertical velocity is going to be 0. It wants to know what is the height of the roof. Okay, so you're looking for vertical distance. Now, I do know you have enough to solve over here for Vx. And usually when you have that, more than likely we're going to ask for that at some point. Just be careful at this. Is you're looking for the height at this point, so don't jump to conclusions and start solving this side just because you have enough. That's actually going to be part B. Okay, so just got to be careful of that, as I may not even ask for that. Okay, I may just be asking for what is the height of the roof. Okay, so just be careful kind of jumping to that conclusion. So that means we did not care about final velocity, so we're going to use that equation again. So d equals 1/2 at squared. I'm just leaving off the VIT since that VI is 0. So d equals 1/2 times negative 9.8 times t squared, so 5.5, and that is squared. Don't forget that. And that's going to give you a distance or height. You can write it as negative or positive, doesn't matter to me. You're going to have a height of 148.23 meters. Okay, B, it says now what is the initial horizontal velocity? Now we're looking for Vx. So remember, Vx equals dx over t. So Vx we don't know. Dx is 65. Time is 5.5. So all I got to do is just divide those. And you're going to need 11.82 meters per second. Okay, and there's your answer for that one. So that was it. So what we're going to do is we're going to move on to the homework page now. So we're going to do pages 9 and 10 in your packet. Okay, so we're going to start off the first one. A plane flying 85 meters per second wishes to drop a package onto a small island 300 meters below. Okay, so I have my plane. I've got an island below. So here's where our island is. Okay, and it's 300 meters above it, so our vertical distance is 300 meters. Okay, and the plane is flying horizontally at 85 meters per second. Okay, it says how far in advance of the island must the package be dropped? So it wants to know what is this distance right here that it needs to release that package so that it will land on that island. So you got to think about it as when a plane drops a package like that, okay, if the plane has a horizontal velocity, so will the package. So if you drop something, it's not going to just go straight down. It's going to have this trajectory because now it's a mixture of both the plane's velocity and the dropping velocity. So I want to know how far in advance do I need to let that thing go. So basically what we're doing is we're looking for dx. Okay, so we're looking for that range. So we're going to set up our t-chart. So Vx, dx, t, and then Daffy t. Okay, so what we're going to do is we're going to fill in things we know. Okay, so my horizontal velocity is going to be 85, so be careful. 85 meters per second, so pay attention to your units. Okay, I've seen people put velocities where distances should be and vice versa. And if you notice the units, if I have 85 meters per second, that is not a distance, that is a velocity. So be careful with that. Now it says the island is 300 meters below, so keyword there is below, that is your vertical distance. So that is negative 300. Now, that is all it gives us, but there's two other things we know that are implied. We have A is negative 9.8, and VI is going to be 0. It wants to know dx, so I'm looking for this. Well, if you noticed, I don't have enough. I don't have time to be able to figure that. But if you look over here, I can find time over here using Daffy T, and then I can bring it over. So this is actually a two-step problem. Okay, so we're going to use that third equation again. So part 1 is d equals 1/2 at squared. So we're going to plug in, so negative 300 equals 1/2 negative 9.8 t squared. So divide both sides by negative 4.9, you're going to get 61.22 equals t squared. So square root both sides, and you get 7.82 seconds. Now, that is not your answer. That is just your time that you can now plug in over here. So step 2 is now you get to do the Vx equals dx over t. So 85 equals dx over 7.82. So multiply both sides by 7.82, and you're going to get a horizontal distance of 664.7 meters. Okay, so that is how far that plane has to release it ahead of time to make it land on that island. So, number 2, a rifle is aimed directly at a bullseye of a target that is 50 meters away. Okay, so we've got a bullet, okay, that is heading horizontally. Okay, and it's going to try to hit a target over here that is 50 meters away. Okay, so I just told you your horizontal distance. Okay, and it's going a speed of 350 meters per second. How far below the eye will the bullet hit? So that means it's going to drop. Okay, so what we want to know is we want to know what is that vertical distance in order to see how far it dropped. So what we're going to do is we're going to set up our Daffy T. So Vx, that was 350. So we got that. So that was our horizontal velocity. Dx equals 50. Okay, that's a horizontal distance. And time, we don't know. Okay, in vertical, we're going to set up our Daffy T. So we are looking for how much it drops. So that is your vertical distance. A is negative 9.8. Okay, VI is going to be 0. Okay, and VF we don't care about. And if you notice, we're also missing time over here. Well, if you notice on this left side, we have enough to solve for time. So step one is we're going to do Vx equals dx over t to solve for time. So 350 equals 50 over t. So be careful with this. You can switch these two. Do not multiply those two because it should make sense. If you multiply 350 times 50, you're going to get a really big number, and it should not take that long for a bullet to hit a target 50 meters away. If it is taking you over hours to hit that target, you messed up. Okay, so 50 divided by 350 is going to give you a time of 0.14 seconds, which makes more sense when we're talking about a bullet. Now, that time can be used here. Now we can do our Daffy T completely. So we're going to use that third equation, d equals 1/2 at squared. Okay, so d equals 1/2 a, which is negative 9.8. T is going to be 0.14, and that is going to be squared. Okay, so if you multiply that all out, you're going to get a distance of 0.10 meters. So that is how far it drops below that target. So you kind of notice this in number one and number two, even though I didn't set it up as A and B, is if you have enough to solve for something, usually it's time, because time is the only thing that can go back and forth. So in number one, we found our time first using Daffy T side, and then we brought it over to the horizontal side. On number two is we used the horizontal side to find T, and then we brought it over to the Daffy T side so it can go back and forth. 3, a rescue line is to be thrown horizontally from a bridge 30 meters above the sea level. Okay, so we're going to draw this out. So 30 meters above sea level, so that's our height. Okay, so our object is being thrown, and it lands 30 meters away. So that is your horizontal distance. With what velocity should it be thrown so it lands on the lifeboat? So that means what is this Vx to make it sure it lands on that lifeboat? So we're going to set up our Vx. So our X side and our Y side. So Vx, dx, and t. And we're going to set up our Daffy T. So again, once you do enough of these, it starts to become very repetitive and second nature. Okay, you just got to make sure you're practicing. Okay, because a lot of time it's just the same steps over and over again. So Vx, I don't know. That's what I'm looking for. I do know my horizontal distance is 30. Okay, but I don't know time. Okay, so I don't have enough to solve for Vx. So I'll let you kind of guess what we're going to do now. And it drops 30 meters, so it's going to be negative 30. A is negative 9.8. Vi is 0 still. And if I need time to find Vx, I'm probably going to look for it over here and then bring it over. So that means Vf still did not matter. So we're going to use equation number 3 again. So step 1, d equals 1/2 at squared. So negative 30 equals 1/2. A is negative 9.8. T squared. So negative 30 divided by negative 4.9 is going to give you 6.12 equals t squared. Don't forget to square root both sides. And you're going to get a time of 2.47 seconds. Okay, so that is not your answer, but that means you can plug this in over here. So step 2 is we're going to do v equals d over t. So Vx we don't know. Dx is 30. And our time is now 2.47. So divide those, and you're going to get a horizontal velocity of 12.15 meters per second. Number 4, a ball is thrown horizontally from a roof on a building at 30 meters per second and lands 60 meters away. Okay, so thrown off horizontally at 30 meters per second. And sorry, this one kind of runs out of room. I'm going to try to fit this all in. Okay, and it lands, let me kind of clear this up a little bit. It lands 60 meters away, so that is your horizontal distance. Okay, so what I'm going to do is I'm going to set up my T-chart over here so I have a little bit more room. Okay, I got X, and I got my Y. So Vx, dx, and T. And we're going to set up our Daffy T. Okay, a ball is thrown horizontally from the roof at 30 meters per second, so that is your horizontal velocity. So that's going to go right here on the left side. And it lands 60 meters away, so it gave you your horizontal distance. Okay, so it says how tall is the building? That means you're looking for vertical distance. So remember, A is negative 9.8, Vi is 0. I do not have enough on that right side to solve for it, So what I'm going to do is I'm going to find time over here on the left side and then bring it over. So I'm going to use V equals D over T. So 30 equals 60 over T. Don't forget to switch these two, so it's 60 divided by 30. That gives you a time of 2 seconds. Okay, so what we're going to do is we're going to plug that into our right side now. So that means we did not care about VF, so D equals 1/2 AT squared. So we're going to plug that in. D equals 1/2, A is negative 9.8, T is going to be 2, and that's going to be squared. Okay, so multiply those, and you get a distance of 19.6 meters. So again, if you wrote negative, that's totally fine. Either way, it works out. Okay, what is the resultant velocity? So again, there's a reason why I bolded this. Resultant means I want to know what is the hypotenuse and what is the angle. So remember, your trajectory looks like this, and you have a horizontal side and a vertical side. So I'm looking for hypotenuse and I'm looking for angle. Okay, now I'm dealing with velocity, so please be careful with this. I've seen people where they do is they take this horizontal distance and they try to plug it in over here, or they take this vertical distance and they try to plug it in here. Again, I'm talking about velocity, not distance. Okay, so I should not be taking any of those distances over there. I'm going to use the velocities instead. Okay, so my horizontal velocity is 30 meters per second. They already told me that, and it's not going to change. Okay, what I don't know is I don't know what is this velocity when it hits the ground that is just vertically. So what we're going to do is we're going to find that first before we can do our Pythagorean theorem stuff. So we're going to set up our Daffy T, because remember, anytime you want to find anything vertical, it needs to be Daffy T. So we are looking for VF now. Okay, A is negative 9.8. Okay, VI is going to be 0. Now, you do have options here. Okay, you can, since you do know the time, so I'm going to use red on this. I know time and I know the height. Okay, so you can use either one. If you want to put in 2 seconds and then leave D off, you can do that. Or you can put 19.6 in for distance and then use the time equation. Either one will get you the same answer. What I'm going to do is I'm going to use the 2 seconds, because that makes me use equation number 1, because that's one of the easiest equations. That's just VF equals VI plus AT. So VF I don't know. VI is 0, so that just disappears. So it's basically A times T. So negative 9.8 times 2. So VF equals negative 19.6 meters per second. Now, that is not my answer. That is just now I know both sides of my triangle. So now we get to do the whole Pythagorean theorem. So square root of A squared plus B squared. So we're going to do the square root of 30 squared plus our negative 19.6 squared. Okay, so that's going to give me a velocity of 35.84 meters per second. Now again, since it's falling, if you wrote negative 35.84, that's totally fine. We'll accept either one. Now if I want to find the angle, so remember our angle is always going to be that inverse tangent of opposite over adjacent. So remember, opposite is your VF. Okay, your Y velocity, so that's going to be negative 19.6 over your adjacent, which is 30. Okay, so that is going to give you an angle of, so again, you can write this negative if you want to, 33.16 degrees below the horizontal. I'm just going to write BH to kind of save some time. Okay, so the point is, when you get to this resultant velocity problem, it's not going to be a bulk of our quiz and test, but it will be on there. Okay, so please don't miss this problem, because if you look back on the one we did on the last page or the last video, okay, it's the exact same steps. You use the Daffy T to find the VF, and then you can just do Pythagorean theorem and inverse tangent. Okay, so if you can just kind of get that process down, makes it a lot easier. So number 5, a cliff jumper moving horizontally at 10 meters per second. Okay, so we're going to draw it out. Moving horizontally at 10 meters per second. Lands 8.5 meters from the base. Okay, so that's not height. Okay, otherwise it would say it would land 8.5 meters below. Okay, so that means I gave you horizontal distance. Okay, from the base of the cliff. It wants to know how high was the cliff. So that means you're looking for vertical distance. So what we're going to do is we're going to set up our T-chart. So VX, DX, T, and Daffy T. Okay, so VX is 10. Okay, we already got that. Okay, DX is 8.5. Okay, time, I don't have it, but I'm pretty sure we're probably going to have to solve for it. Okay, it wants to know how high was the cliff, so you're looking for your vertical distance. A is negative 9.8, VI is 0. Okay, so yep, I'm going to need to solve for this time to bring it over. So step 1, we're going to do V equals D over T. So 10 equals 8.5 over T. So flip the 10 and the T. So 8.5 divided by 10 is going to give you 0.85 seconds. So now what I can do is I can plug that in here. Okay, so now we're going to use that third equation again because I don't care about VF. So D equals 1/2 AT squared. A is negative 9.8. T is 0.85, and that is squared. Okay, so that's going to give you a distance of 3.54 meters. Number 6, a diver running at 3.6 meters per second dives out horizontally. Okay, so I have a horizontal velocity of 3.6 meters per second. Okay, dives out horizontally from the edge of the vertical cliff and reaches the water in 2 seconds later. Okay, so that's all it gave us. How high is the cliff? So that means you're looking for your vertical distance. So let's set up our T-chart. So again, feel free to pause this and stuff. I know I'm kind of trying to go fast. I don't just want to make the video too long. So our Vx is going to be 3.6. Okay, so we have that. Okay, dx we don't know. Time we do know, 2.0. Okay, and we can put that 2.0 on both sides. And we know A is negative 9.8, and VI is going to be 0. It wants to know how high is the cliff, so we're looking for vertical distance. So we're going to use that Daffy T side to figure out how high it is. Okay, so be careful with this, as I'm looking for vertical distance. So some may see this left side and say, oh, this is almost done. All I got to do is V equals D over T, and you start jumping the gun. Okay, that is horizontal distance, so just make sure don't jump the gun on that. So that will come in part B, so just be careful. So we're going to use Daffy T to figure out that. So we're going to use that third equation again. So D equals 1/2 AT squared. Hopefully you're starting to get a pattern now. So D equals 1/2 times negative 9.8 times 2 squared. And that's going to give you a distance of 19.6 meters. Okay, so that is how far below it landed below the cliff. B says how far from the base. That means you're looking for dx now. So we're going to do V equals D over T. Okay, so 3.6 equals dx over 2. Okay, multiply both sides by 2, and you get dx equals 7.2 meters. Last one. A bullet is fired horizontally with a height of 7.84 meters, hits the ground 2,400 meters away. With what velocity did the bullet leave the gun? Okay, so what we're going to do is we're going to draw our bullet. Okay, it's fired from a height of 7.84 meters, so that is our vertical distance. And it lands 2,400 meters away. Okay, so what we're going to do is we're going to set up our T-chart. So Vx, dx, and T, and then Daffy T vertically. Okay, so Vx didn't tell us that. It actually is looking for that. What is the velocity did the bullet leave the gun? So that means we are looking for this. Dx we know is 2,400. Okay. T we don't know. Okay. Our vertical distance is 7.84, so negative 7.84. Okay. A is negative 9.8. VI is still 0. So if I'm looking for Vx, I need to know what is time. So that means I got to find time on the right side, and then I can bring it over. So we're going to do step 1. We're going to do that Daffy T. So use equation 3. So negative 7.84 equals 1/2 A, which is negative 9.8, T squared. So divide both sides by negative 4.9. You get 1.6 equals T squared. Okay, so square root both sides. You get a time of 1.26 seconds. Okay, now that time is, I can bring it over here now, and now I can do V equals D over T. So Vx equals dx over T, so 2,400 over your T, which is 1.26. And you're going to get a velocity of 1,904.76 meters per second. And that'll end that one.